Good afternoon. Here are the notes for Monday, October the 2nd. These notes are continuing from Friday. On Friday, we learned I can solve polynomial equations. Well, today we're going to continue with this learning target. I can solve polynomial equations. Alright, if you have your notebook, I'm on page 19 of your notes, page 19 of your notes. And I'm going to start off with number 6. I'm going to skip around, but I'm going to do number 6 as a review. 4x cubed minus 32 equals 0. Okay, I want to solve this equation. You want to solve them by factoring if possible. Can't factor, then you must go on and try the quadratic formula. But you can only use the quadratic formula if it is a quadratic. Okay? So I start with this problem. Is it difference of squares? No. Is it bust them up? No. Easy? No. Grouping? No. So my last resort is GCF. So I'm going to take a 4 out. Okay. Once I take this 4 out, I'm left with this x cubed minus 8 in the parentheses. Well, I do not have to worry about this 4 necessarily because it's not a variable. So I don't have to worry with, there's not a variable with the 4, so I do not have to worry about that. So I'm just going to set this part in parentheses equal to 0. Now, we talked about this on Friday. This is a type of factoring. Remember, you can have sum of cubes and the difference of cubes. Okay. Remember, you can only have difference of squares, but for cubes you can have either sum and difference. So, for this particular problem here, when you are factoring perfect cubes, you're going to have a small parentheses for the binomial and a large parentheses for the trinomial. Okay. So in this first parentheses, you take the cube root of each of them. Cube root of x cubed is x. Cube root of 8 is 2. We'll come back and do the signs in a little bit. Now, to get your 3 terms in your trinomial, like I said, you have 3 terms. For this first blank, you square this first term here. That's going to be x squared. For the second blank, you multiply these two together. It's 2x. And for the last term, you square it, which is 4. And then you're going to use the method SOAP for your signs. S stands for the same sign as the original. That's going to be a minus. Opposite the minus, which is a positive, always positive on the last one. So same as the original, opposite, always positive. Then set each parenthesis equal to 0. Alright, so I got 1, 0, x equals 2. If I was to graph this original, it will cross at 2. Now I'm going to set this parenthesis equal to 0 as well. It appears to be, it appears to be easy factoring. However, you can't think of 2 numbers and multiply to give you 4, add to give you 2, so you got to use the quadratic formula. So I'm going to use negative b plus or minus square root of b squared minus 4ac over 2a. Opposite of b is negative 2 plus or minus 2 squared minus 4 times 1 times 4 all over 2 times 1. I'm going to bring this up here so you can see it. Negative 2 plus or minus 4 minus 16 all over 2. Negative 2 plus or minus square root of negative 12 over 2. Break 12 down. 2, 4 times 3. Have a group of 2, so you can bring that 2 out. And since there's a negative under the radical, you know that's going to be an imaginary unit here. So I'm going to when I bring this 2 out, I'm going to bring an I out as well and leaving that 3 under the radical. So your zeros are x equals 2 and x equals this complex number here. So you have a total of 3 zeros. 1, 2, 3. This counts twice because you have plus or minus. Now, so you have 3 zeros. Now I'm going to ask you a question. How many are real? This is the only real one. So you have 1 real and 2 complex for a total of 3. Okay? Alright, I'm going to look at number 8. Number 8. We have x to the 4th plus 11x squared equals negative 18. The degree is 4, making this polynomial equation quartic. However, it is not in standard form. To be in standard form, all polynomial equations have to be equal to 0. So I'm going to move that over. Now, this is not perfect cube, so you can't factor that way. That's not difference of squares. It's not bust them up, not easy, not grouping GCF. So, Mr. Escher, what do we do? Well, guys, you have to think about, this looks very similar to the format x squared plus 11x plus 18, which is easy. That looks very similar to that, so you can use this method of factoring for this. I'm going to put 2 parentheses down. Instead of putting an x and an x here like I would on this particular problem, you would put x squared, x squared. They're just not, that was just an example, so I'll mark that out. It has nothing to do with this problem. Now, it's got to multiply to give you 18, add to give you 11. That's 9 and 2. Okay? Now, you said, now, Mr. Escher, we went from quartic to we got 2 quadratics in this parentheses. So, we got to see if we can factor it. Well, that can't be factored. That is not difference of squares. Okay, so you can either use quadratic formula, which will give you the answer, or since it's in this format, variable squared plus some constant, you can just move that constant over. It's a negative 9. Take the square root. Remember, when you take the square root, it's plus or minus. And since there's a negative under that square root, it's going to be I. You got to include that I. Here I'm going to move this over. That's going to be negative 2. Take the square root. You're taking the square root of a negative. So remember, it's going to be a plus or minus I. And since I do not know the square root of 2, I just leave that as that. But I had to bring that I out to combat that negative under the radical. So Mr. I don't understand how to do that. Just do the quadratic formula. You get the same answers. So in this case, we do have the maximum number of zeros we could have was 4. We have 1, 2, 3, 4. In this case, we have 0 real. So we have 4 total zeros. 0 real. 4 complex. Okay. Alright, let's look at number 9. X cubed plus 3x squared plus 4x plus 12. Okay? Let's count the number of terms here. 1, 2, 3, 4. That's calling out for grouping. That's a prime candidate for grouping. Okay, I'm going to take a 1 out of this first parentheses. X squared. Here I can take a 4 out, a positive 4. I take a positive 4 because that first term, this second parentheses, is positive. Starting back, it is a cubic, so the maximum number of zeros I can have is 3. And we're going to learn the name of that theorem is the fundamental theorem of algebra. That tells you how many the maximum number of zeros it can have tomorrow. Alright, so I'm going to set this first one equal to 0. X plus 3 equals 0 as x equals negative 3. Set this second parentheses equal to 0. It's in that format of a variable squared plus some number. You can just move this over. Or you could do the quadratic formula, but this cannot be factored. Remember, when it comes to a quadratic, you got to say, can it be factored? This cannot be factored, so you have to use either, if it's in this form, you can move it over, or the quadratic formula. Take the square root of both sides. That's x equals plus or minus 2i. So I have 1, 2, 3. 1, 2, 3 zeros. 1 is real, 2 is complex. And I can show you, since this cannot be factored, you could do the quadratic formula. And if you don't know when to do this little shortcut like this, just do the quadratic formula if you cannot factor and you get the answer correct each time. Negative b, there's no b in this because the b is the coefficient in front of just the x, so that would be 0 plus or minus 0 squared minus 4 times your a times your c all over 2 times 1. 0 plus or minus square root of negative 16 over 2 plus or minus square root of negative 16, that's going to be plus or minus 4i over 2, which is equal to 2i. See, I got the same thing either way. But your zeros are negative 3 and plus or minus 2i. For number 9. We're going to do one more. Number 10. 2x cubed minus x squared minus 6x plus 3 equals 0. It has 4 terms, so this is shouting out grouping as well. Here I can take an x squared out. That leaves a 2x minus 1. Here I can take a negative 3 out, and I take a negative because that first term is negative. That leaves a 2x minus 1. 3 divided by negative 3 is a negative 1. This will give me 2x minus 1 and x squared minus 3. I'm going to set that equal to 0. 2x minus 1 equals 0. X equals 1/2. You should be able to do that in your head. X squared minus 3 equals 0. I have a quadratic equation. First thing I'm going to do is try to factor it. I can't factor that. Now, I could use the quadratic formula, but since it's in this format right here, I could use that shortcut and just bring this over here. Take the square root of both sides. Do you know the square root of 3? You do not. Now, but when you take the square root, it's plus or minus the square root of 3. So, Mr. S, where's your I? There was not a negative under the radical, so I do not need an I right here. So, in this problem, I can have the maximum number of zeros is 3. Here's 1, and here's the other 2. 1, 2, 3. None of them are imaginary because there's no I. It's just 3 real. Now, I want you to understand, here I could do the shortcut and move this over. But if I was given something like this, and I'm making this totally up, and you had something like this, equals 0, I cannot factor that. I have to use quadratic formula on something like this. I can't do no shortcut like this over here. Cannot do that. That's only when you have a variable squared and that number you can just move over easily. On this, I will be forced to use the quadratic formula. Just a side note. But tomorrow we will talk about what we would do when it cannot be factored in order to find the zeros. Remember to do your homework for tonight.